Hello and welcome. Today we're going to explore the practical applications of fractions, decimals, and percentages. Our goal is to see how these mathematical tools are used in real-world and problem-solving context. By the end of this video, you will be able to use fractions to express ratios, scale quantities, solve measurement problems, interpret data, and even simplify algebraic expressions. Let's get started. First up, let's talk about ratios and proportions. Fractions are a powerful way to express ratios, which show how one quantity compares to another or to a total. A ratio is a comparison of two numbers, and a fraction is a way to write that comparison. For example, imagine a survey where 3 out of 5 students prefer online learning. We can represent this with 5 student icons and highlight 3 of them. This is a ratio of 3 to 5. Which we can write as 3 to 5. As a fraction, this is 3/5, or 3/5. To convert this fraction to a decimal, we divide the numerator by the denominator. So 3 divided by 5 equals 0.6. And to get a percentage, we multiply the decimal by 100. 0.6 times 100 gives us 60%. So you can see that fractions, ratios, decimals, and percentages are all just different ways of expressing the same relationship. They are different forms of the same number. Next, let's look at how fractions help us with scaling problems, like in a recipe. In scaling, we use fractions to adjust quantities accurately, either up or down. Imagine a recipe for 4 people that uses 200 grams of flour. Here's our recipe card, showing 200 grams of flour for 4 people. What if we need to scale this up for 6 people? First, we need to find our scaling factor. The scaling factor is the new number of servings divided by the original number of servings. So 6 divided by 4, which simplifies to 3/2. Now we multiply the original quantity of flour by this scaling factor. 200 grams times 3/2 gives us 300 grams. So for 6 people, you'll need 300 grams of flour. We can also scale down. What if you only need half the recipe? In this case, our scaling factor is 1/2. We simply multiply all quantities in the recipe by 1/2. So 200 grams of flour becomes 100 grams. Fractions make it easy to adjust recipes for any number of guests. Fractions are also essential in measurement, helping us find parts of distances, times, or other continuous quantities. Let's see how fractions help us with measurement problems. Consider this problem. A car travels 3/4 of a 120-kilometer journey. How far has it traveled? We have a total distance of 120 kilometers, and the car has covered 3/4 of it. To find the distance covered, we need to calculate 3/4 of 120. In mathematics, the word of often means multiplication. So we multiply 3/4 by 120. We can write 120 as 120 over 1. Then we multiply the numerators and the denominators. This gives us 360 divided by 4, which equals 90. So the car has traveled 90 kilometers. The car has completed 90 kilometers of its journey, with 30 kilometers remaining. Fractions allow us to easily calculate parts of a whole measurement. Fractions are also incredibly useful for interpreting real-world data, especially when combined with percentages. They help us describe parts of data sets and can be easily converted into percentages or ratios for better understanding. Let's look at a school survey. The results are shown in this pie chart. The survey shows that 2/5 of students chose football and 1/4 chose basketball. The rest of the students chose cricket. How can we find the fraction of students who chose cricket? The entire pie chart represents the whole, which is 1. So we can subtract the fractions for football and basketball from 1. The calculation is 1 minus the sum of 2/5 and 1/4. To add fractions, we need a common denominator. The least common multiple of 5 and 4 is 20. So 2/5 becomes 8/20, and 1/4 becomes 5/20. Their sum is 13/20. Now we subtract 13/20 from 1, which is 20/20. This gives us 7/20. So 7/20 of the students chose cricket. To make this easier to understand, let's convert 7/20 to a percentage. We divide 7 by 20 to get 0.35, and then multiply by 100 to get 35%. So 35% of students prefer cricket. As you can see, whether you're reading charts, calculating portions, or comparing data, Fractions make interpretation straightforward and accurate. Fractions aren't just for numbers. They're a fundamental part of algebra too. In algebra, we use the same fraction rules to simplify expressions or solve equations. Let's look at an example of simplifying an algebraic fraction. We want to simplify the expression 28x over 144y. To do this, we find the greatest common factor of the numerator and the denominator. The greatest common factor of 28 and 144 is 4. We can rewrite 28 as 4 times 7 and 144 as 4 times 36. Now, we can cancel out the common factor of 4 from the numerator and the denominator. This leaves us with the simplified expression 7x over 36y. Now, let's try solving an equation that involves fractions. We want to solve the equation 2x over 9 equals 4 2/3. First, let's convert the mixed number on the right side into an improper fraction. 4 2/3 is the same as 14 over 3. So our equation is now 2x over 9 equals 14 over 3. To solve for x, we can multiply both sides of the equation by 9. On the left, the 9's cancel out, leaving us with 2x. On the right, 9 divided by 3 is 3, so we have 14 times 3, which is 42. Finally, we divide both sides by 2 to find that x equals 21. As you can see, the rules for fractions apply directly to algebra, making it a powerful tool for solving equations. Let's quickly summarize what we've learned about the applications of fractions. Fractions are not just numbers. They are tools for reasoning, comparison, and precision. We've seen how they are used to express ratios, scale recipes, measure quantities, interpret data, and solve algebraic equations. They connect to nearly every topic you'll encounter in mathematics and in your daily life. Understanding fractions is key to understanding the relationships between numbers. Now that we've seen how useful fractions are, let's look at some common mistakes students make and how to avoid them. By understanding these pitfalls, you can improve your accuracy and confidence when working with fractions. The first common mistake is adding denominators. Let's look at an incorrect example. If you try to add 1/2 and 1/3 by adding the numerators and the denominators, you would get 2/5. This is wrong. Remember, you can only add or subtract fractions if they have the same denominator. You must find a common denominator first. The correct way is to find the least common multiple of 2 and 3, which is 6. We convert 1/2 to 3/6 and 1/3 to 2/6. Now we can add them to get 5/6. This is the correct answer. Another common mistake is not simplifying before multiplying or dividing. Let's take the example of multiplying 6/14 by 7/9. You could multiply straight across to get 42 over 126 and then simplify, but there's an easier way. Look for common factors between any numerator and any denominator. Notice that 7 is a factor of both 7 and 14. We can cancel them out, leaving 1 and 2. Now, we can also see that 6 and 9 share a common factor of 3. We can cancel them out, leaving 2 and 3. Finally, the 2's cancel out, leaving us with 1/3. Simplifying first makes the number smaller and the calculation much easier. A very important tip is to always do a sense check of your answer. This means asking yourself if the answer makes sense. For example, what is 1/2 of 60? You know that 1/2 is less than 1, so 1/2 of 60 must be less than 60. The correct answer is 30. If you made a mistake and got an answer like 120, you should immediately realize something is wrong. If your answer is larger than the original number when you're taking a fraction of it, you've likely made a mistake. Always take a moment to estimate or think about the size of your answer. This simple step can catch many errors. Finally, let's address a common mistake in fraction division, forgetting to flip the second fraction. The rule for dividing fractions is to multiply by the reciprocal of the second fraction. Let's look at an example. 3/4 divided by 2/5. The correct way to solve this is to keep the first fraction, 3/4, change the division sign to multiplication, and flip the second fraction, 2/5, to its reciprocal 5/2. Now we multiply across. 3 times 5 is 15, and 4 times 2 is 8. The answer is 15/8. which can be written as the mixed number 1 and 7/8. A common mistake is to multiply without flipping, which would give you 6/20, a completely different and incorrect answer. Always remember to flip the second fraction when dividing. Let's recap our tips for mastering fractions. First, always estimate before you finalize your answer. This helps you catch mistakes early. Second, always simplify your fractions. It makes calculations easier and your answers clearer. Third, use decimals or percentages to check your sense. If you're unsure, converting to a decimal can give you a quick check. Think smart, simplify, and check. That's the key to mastering fractions and using them effectively in all their applications. Thank you for watching. I hope this has helped you see the power and importance of fractions in the world around us.